This topic's going to show up a lot in your programming languages class. And that is creating recursively designed or defined sets and structures recursively. This also comes up in data structures as well. Trees, nodes in a tree are recursively created. A linked list is recursively created. So there's a lot of these that you may have already seen before, and that's okay, that's great. But remember, every time we talk about anything recursive, it's going to have a base step and it's going to have a recursive call in there as well. So all of those are going to have that. Now, just heads up, I'm going to show you 4 different examples of this here. There's a couple of examples that use string as an application. The sigma is meant for the alphabet of characters that you can use, and sigma star is a set of strings using that same alphabet. And lambda is an empty set of empty string. Let's just put it that way, that we can add to later on. But I haven't gotten to strings yet. Let me just do the first simple example of just a set of, well, our integer values that are greater than 0. So what we can do is we can have a base step as 1 is an element within or a subset of our natural numbers. A recursive call is if n is within the natural set, then n plus 1 is also in the natural set of values and following the pattern of n. So initially, 0 is our n, then we have 0 plus 1 equals 1, and then 0 plus 1 plus 1 equals 1. So notice again, there's our stable force in our recursive call, and then our changing value in our recursive call is beside it and holds it and helps it develop that overall set. Here's 2 more examples, but let me go with the first one here. This one's asking to create a subset of integers defined recursively by a base step, which it already gives you. 7 is going to be an element within our set of S. And then if, or recursive call, if X is an element within our set S and Y is our value, an element within our subset of S, then we have X plus Y as our subset. So how's this going to work out? This one's asking you to create the set. So notice it says, list the elements of S produced by the first 5 applications of the definition. And by the way, you're going to have a lot of this in the book. First is our base condition. And then we're going to follow exactly like it said, is that, hey, if X is an element within S, it is, and then Y is, then we're going to add the 2 together and go ahead and get our new value. And then notice we're going to use that again. That 7 is going to be brought down plus 14. And again, that's our 14 from our previous one that we had right here. So notice how it's kind of highlighting here on which ones are being used over and over again in our recursive call. Our foundation or our stable portion of the recursive call is being highlighted there, and that's our 7 plus. Then we'll get our first 5 elements within our set of 7, 14, 21, 28, and 35. The last set or structure I wanted to show you was string concatenation. So just be careful. There's a couple of different values here. W1 is abra, W2 is cadabra. At the end of it, we're going to be putting the 2 together and having abracadabra. So I wanted to make sure you understood the algorithm, is that we're going to go through all of W1 first and then start adding things to A. And that's exactly what this is doing, is that it's checking to see if there's any more elements in W2 so that then we can go ahead and add it to the end of that previous string that was set before. So first it would have been, I'm going to use my lines to help me out, would have been abra. Our next recursive call would have added the C. Our next recursive call would have added the A. And it keeps going from there using the equation that we have right here. There's a couple of different examples we have for recursive functions. Let's see what we get into next.